Hey everyone, Chang here. This is the skill building video series. For today's topic, we're going to talk about vertex form and how it actually helps you graph quadratic equations or parabolas. Now, here is the equation for vertex form. Y equals a times x minus h squared plus k. Now, we know that h and k is the coordinate for the vertex. H is the x coordinate, k is the y coordinate. Now, this here is a generalized form of a transformed function. So in the future, we will talk about transforming function in general. But what it means is that we have this what we call parent function. We know that the graph itself is gonna look like this in one way, shape, or form. And after that, we alter it based on the numbers that's given to us. So what do I mean by that? Well, the parent function of a quadratic equation is basically the most simple form of quadratic equation. Y equals x squared. Now, when you graph this, basically you start in the origin and it's going to look like a U going up. Okay? Now, this is a transformed version of the original. This is what we call parent function, the most simplest form. In that afterwards, all these addition of h, k, and a will allow us to, from this original function, to move it around, compress or expand it, flip it over, so that it matches the exact equation that we want. Now, remember this as the parent form, and then I'm going to show you, after we get an equation into vertex form, how it differs from the parent form. So let's begin. So for our first problem, we're going to work on this one. This is not in vertex form. I'm just going to walk over very quickly how to get this to vertex form. I have an entire video on doing that, but this one is just the first problem, so let's just go over it really quickly. Now, this is standard form. We want it in vertex form, so I'm going to subtract 11 on both sides. You have y minus 11 equals x squared plus 6x. After completing the square, I'm just going to add 3 squared here and add 3 squared here. So basically I have y minus 11 plus 9 equals, and then this form is a complete or perfect square. In this case, it's just going to be x plus 3 squared. Okay, this combines right here. So we have basically y minus 2 equals x plus 3 squared. Add the 2 on both sides, and you have y equals x plus 3 squared plus 2. Okay, so this right here, standard form to vertex form. Okay, so I'm going to erase all this, and then we're going to use this basically vertex form and graph it. All right, so here we have it. Standard form, vertex form. We know that from the vertex form, we have our vertex. -3, and the reason for -3 instead of a +3 is because in our vertex form it's a minus h. Here technically it's just minus a -3. Hopefully you guys can see that, right? That's why we have a -3 on the x coordinate. The k itself is 2, which is our y coordinate. Now, if you have to actually be super specific and graph it as precise as possible, then you're kind of out of luck. That's all you get, right? You have your vertex. Then you start plugging in x and y into a t-chart and then try to be as precise as possible. Now, most of the time, it's not. It requires you to actually be, you could sketch it, right? At least know the general behavior of the parabola. So that's why I have this right here. This, remember, is our parent function, the most simplest form of a parabola. It starts in the origin, it's a U shape. Now here, the vertex form is actually known as the transformed function of the parent function. In this case, the parabola. So I'm going to write several more equations. I'm going to show you what the graph looks like and see the behavior compared to the parent function. And in the end, the actual, problem, the actual equation itself. So y equals x squared looks like this. Y equals x squared plus 2. Notice this. X squared is what makes that U shape. Plus 2 means that you're just adding 2 to every single point on the parabola. So, rather than it starting at the origin, all it is that the U shape now starts 2 up and then still maintain its U shape. Next one, y equals x plus 3 squared. Okay? From the vertex, we can sort of guess what it means. If this plus 2 means that we're bringing every single point of the parabola up 2, this right here, where we know the vertex itself is going to be moving over to -3. Rather than starting at the origin, now we're just moving right here, 1, 2, 3 to -3, and our parabola is going to start right here. That's what that looks like. So, if on the outside, not in the square itself, on the outside you have that number plus 2, and it moves everything up 2. Inside moves it left, or in this case left 3, right? If I were to combine it, y equals x plus 3, we know now looks like this, squared, plus 2, we know that moves everything up. The actual graph itself, 1, 2, 3, 1, 2, this is where your vertex is, and then your graph is going to look like that. Now, this kind of reasoning, this behavior works with every single quadratic or parabola that's in vertex form. So that actually tells us a lot more than just a vertex itself. H, the value of the -3 in this case, tells us if it's moving to the left or the right. So we're just going to call this horizontal shift. See, there's not a lot of room. Horizontal shift. I don't know if you guys can see that very well. Horizontal shift. Okay. K itself is basically on the outside. That tells us to move it up or down. This is our vertical shift. Vertical shift. Okay. The A itself actually tells us two things. Is it opening up? Is the U shape facing up or facing down? Right, so it's going to be up or down. Or down. But it also tells us if the U shape is going to be skinnier or is it going to be wider, right? Skinnier or wider. Skinny or wide. Okay, I'm not going to focus on skinny or wide that much. I don't think it's personally very important, even though it sort of is. The horizontal vertical shift, the up or down, I feel like is the most important. Now, well, that's for this graph. But I want you to know this. Horizontal shift is our H. Well, in this case, because from the vertex we know that it's negative, we're moving to the left. Now, I've seen people try to memorize this, and the way they memorize it is that inside, and this is what scares me, inside you're technically doing the opposite, right? So since it's a +3, a lot of people, if they try to memorize it, might make the mistake thinking, well, that's a +3, so I'm going to move everything to the right. That's not the case. Remember, in our vertex form, it's actually a -h. So technically, in this case, it's a minus and it's a negative number. The negative number is the most important. Because it's a negative number, you're actually moving everything to the left, not the right, right? So if it happens to be a minus some number, so instead of a +3, and this is a -3, ignoring that, just a -3, then technically this graph is going to shift over 3 times to the right. So to memorize this, if you really want to, you have to remember the opposite. If it's a plus some number in there, technically you're going to the left. If it's a minus some number, then technically you're going to the right. Okay, so that's one thing. The K I love. It's just a vertical shift. If it's a positive number, you're moving the whole thing up. If this is a negative number, let's just say -1, then you move it down 1. If it's a -7, it moves it down 7. If this is a plus, for example, 8, then you just move it up 8. Right? That's easy to remember. Now, the last one is A. If it's positive, you're opening up. Plain and simple. If it's negative, then the whole thing flips, you're opening down. Skinny and wide. And this is the one where you can sort of just memorize, but I feel like it lets you know, but it doesn't really help you nearly as much since you're sketching the graph anyway. If the A itself is bigger than 1, right? It gets larger, 2, 3, 4, 100, whatever. The graph itself gets skinnier. And the reason for that is because basically everything shoots up super quick. If it's smaller than 1, but it doesn't hit 0, right? Then it actually gets wider because all this is actually takes a lot longer to get up, right? So rather than it just increasing by 1, it might increase by like less than 1, like 1/2 or 1/4, depending on A. So that's why I don't really like the whole skinny and wide thing, even though it does tell you that. It's not as helpful because, you know, when you sketch graph, it might not be as precise. So hopefully this helps. Up and down, skinny and wide is what A tells you. H tells you horizontal shift, left or right. K tells you vertical shift. So even though this is a vertex form and it seems like only tells us the vertex, it actually tells us exactly how the parabola behaves. Let's try it on the next problem. All right, so here's our next problem. Y equals negative, parentheses, x minus 7 squared plus 1. Now, before we even graph it, we have our parent function, which we can use as reference. We have this right here, which I'm hoping that even though it's kind of messy, we remember what it is. Let's just look at it very quickly, okay? Several question, is it opening up or down? Well, this is a negative, so it's opening down, all right? So open, down. Let's just write out its behavior first. Well, in here, it says a minus 7. Now, once again, we're tempted to say because it's minus 7, it's actually moving to the left. No, that's not the case. Remember, this is a negative or minus h. So the h itself, the actual number h, is a positive 7. So we're actually going to move to the right. So to the right, 7, right? Plus 7. Let's just say right plus 7. Okay, now the last thing we need to know is its vertical shift, right? Is it moving up or down? If it's moving up or is it moving down, how high is it going? How low is it going? Well, in this case, it's a plus 1. Positive, so it's moving up. Shift, the number itself, 1. So it's going to move up 1. Okay, so that means before even starting the graph, I already have a rough idea what it looks like. Well, okay. Y equals negative x minus 7 squared plus 1. Okay. Originally it starts in the origin. We don't want that anymore. Well, we know that it opens down, so it doesn't even behave this way. It actually flips over down this way. So over to the 7, right? 1, 2, 3, 4, 5, 6, 7, and it goes up 1. That's our vertex itself. We also know that it opens downward, so rather than going like a U shape up, it actually looks like that. And just like that, right, without doing any super complicated computation, we immediately know this graph right here looks roughly like that. All right, let's look at this one. We have y equals 3 times x minus 1 squared minus 4. Once again, we're just going to write all the information out so that we know exactly what it is before we even have to graph it. Okay. Positive number opens up. Now, I put the 3 there on purpose because guess what? Remember, since this is a 3, it technically is a little skinnier too. So we can just say skinnier. So if this is what it roughly looks like, then the next one we draw is going to be skinnier than that. Skinnier, my spelling is terrible. Skinnier. All right, so the other one, let's see what else. Here, inside, what does it tells us? Well, this is a minus 1. Technically, h itself is positive, so if you're moving to the right, 1. So let's just say plus 1. Okay? What else do we know? Vertical, this is a minus 4, so technically you're not moving up, you're moving down. Right? So it's going to be down 4. Okay, cool. Anything else? I think we're good. So we can sort of guess what it looks like. Y equals 3 times x minus 1 squared minus 4. Here it is. Now, we want it to open up, so it's going to look like a U. It's going to be a little skinnier. It's going to move to the right 1 time, so here's 1. And then move down 4 times. 1, 2, 3, 4. Once again, that's also where our vertex is. And then we're opening up. Skinnier than that, so I'm just going to exaggerate, so it's going to look something like that, probably. Okay, so I mean, you can also check. I mean, this is probably not accurate. It's in terms of the intercept itself. Check for that, but at least the sketch itself, the graph looks something like this. Now, for the last problem, let's see if you guys can follow along. you for watching this video on vertex form and how it helps in terms of graphing quadratic equation. See you in the next video.